Okay, today we're going to be doing section 9.5, and it's titled the dot product. Now, we know that when we use the word product, we're talking about multiplication. But of course, with vectors, this is going to be more than just normal multiplication. It's not just multiplication of values, it's multiplication of directions as well. So the definition of dot product between two vectors, so let's say I have vector v and vector w, and I want to do the dot product. First of all, we use the dot symbol for multiplication because the X symbol is actually a different type of product, which we're going to learn later in this unit. So it's v dot w is equal to a1 times a2 plus b1 times b2. So let's assume that vector v is a1i plus b1j, and vector w is a2i plus b2j. Then in order to do the dot product, we're going to multiply a1 times a2, get an answer, multiply b1 times b2, get an answer, and then add them together. So when I take two vectors, let's start off with two vectors, 2i minus 3j, we'll call that v, and 5i plus 3j, and we'll call that w. And I want to do the dot product of v and w. Then I am going to multiply the a value from vector v times the a value from vector w, which would be 2 times 5. And I'm going to add that to the b value from v times the b value from w. So that would be negative 3 times 3. When I multiply those two together, then I end up getting a value of 1. So the dot product of vw is 1. Now I want to show you the dot product of WV. When you have the dot product of WV, we would do 5 times 2 plus 3 times negative 3. And you'll notice that that is 10 minus 9, which is still equal to 1. So because of that, we know that the dot product is commutative. The dot product is also distributive. When you multiply, when you find the dot product of a vector with itself, you will always end up with the magnitude of that vector squared. So let's take v, which was 2i minus 3j, and do the dot product with itself. Now that means I'm going to do 2 times 2 plus 3, negative 3 times negative 3. So that would be 4 plus 9 is 13. Now I don't know if you remember that this particular vector, when we were working in section 9.4, had a magnitude of the square root of 13. So the magnitude of v was the square root of 13. Well, notice the magnitude of square root of 13, if we square that value, it's equal to 13. So a vector times itself, or a vector dot itself, is going to be the magnitude squared.